This video is to help you review the concepts of how the process works for a one-step equation. Now the problems I'm giving you are simple. You can actually look at them and probably figure out the answer. The key to this is we're looking at the process, because eventually these can get a lot more complicated and some will be done without even numbers. Alright, so here's an example, simple example, x plus 5 equals 12. Alright, so the first thing I want to want you to think about is what is the variable. So the first thing you need to kind of remember is what is the definition of a variable. A variable is a letter or symbol that represents an unknown. It's a letter or symbol. Alright, and that symbol could be like a box, it could be a circle, a triangle, a star, it could be anything like that. It could be a dollar sign. I mean, it could be anything that it represents, that someone's put as a symbol. A letter, you know, most of the commons are X and Y, but you could have anything. You could have T, P, it's any letter in the alphabet. Alright, so a variable is a letter or symbol that represents an unknown. That means we have not been told what the value of that letter is, but we are going to find out by using the algebraic method of one-step equation. Now, I have a little system. I like this little system. It works real well. You just have to kind of remember and ask yourself these questions. First thing is, what's the variable? If you look at this, you know the variable is x. X is going to be my variable in this situation. And we want to know what is being, the next question is, what's being done to the variable? Alright, so we want to look at what's being done to the variable. So look at the x. What's being done to x? And if you notice, it's being added by 5. The next thing we say is we do the opposite to both sides. Do the opposite to both sides. Alright, so here we go. What's my variable? It's x. What's being done to x? It's being added by 5. What's the opposite of add 5? We're going to subtract 5 to both sides of the equal sign. Alright, if you look, we're going to bring the x on down, but I want you to pay close attention to this guy here. You see this guy here? Alright, so if you look right here, this little section here, this has a special name. If you notice, one says plus 5 and the other is minus 5. This is what we call a zero pair. Think about it. 0, if you add 5 and subtract 5, you get 0. It's a pair of numbers that are opposite of each other that give you a 0 answer. And so this does. It kind of like they cancel each other out. Alright, so then we'll keep going. 12 minus 5 is 7. Now, when we notice this, we notice that we have to pay attention to the signs. If you notice, you have a plus 12 and you have a minus 5. When the signs are the same, you would add them. And what I mean by signs are the same, they're either both plus or both negative. You would add the number and keep the sign of what they have. However, in this case, we have a plus and we have a minus. So we have a plus and we have a minus. Because the signs are different, we actually subtract the numbers. So 12 minus 5 is 7. And we go with the sign of the bigger number. And the bigger number is 12. It's positive, so my answer is 12. Now, how would I check this? You should be able to just plug in your 7 into the x value, because if you notice, x equals 7. So if I take that and I move it in for x, I'm saying 5 plus 7 is, it should be 12. In this case, yes it is. So the answer is 12. So let's try another one. Let's say that we have, this is example 2. Let's say we have x minus 6 equals 7. Alright, so let's ask ourselves the same question. What's my variable? My variable is x. What's being done to x? It's being subtracted by 6. What's the opposite of subtract by 6? You should say add 6 to both sides. Alright, do you remember what this is called right here? Should be a zero pair, so it cancels each other out. You'll bring down your x. Watch your sign here. I have a plus and a plus. That means I add the numbers, so it's 13, and they're both positive. So my answer is plus 13. Excuse me. Then you could now you can take this answer for x, 13, and you can plug it back into the original equation. 13 minus 6, that should equal 7, and it does. So we know our answer is right. Excuse me. All right, so let's look at another one. There's another example. Example 3. Let's say we have something like this. All right, same principle. Notice there's no plus or minus in this one. What's the variable? Well, you should say the variable is x. What's being done to x? Being multiplied by 3. So the opposite of multiply by 3 is divide both sides by 3. Now you got to be careful here. What is 3 divided by 3? You should say 1. So 3 divided by 3 is 1. If you notice I drew a line through them, it looks like a big 1. So 1 times x, think about it, 1 times x is going to be x. So really there's imaginary 1 here. It's really 1x, but we're going to just say x. Alright, and 3 goes into 9, so you're just saying what is 3 going into 9? You should say that answer is 3 as well. Now look, we could plug this in just like we did before. This 3 goes in for there. You're multiplying 3 times 3, and 3 times 3 is 9, and the answer is supposed to be 9. So that worked out great. Let's try some more. What if we had an example like this? Alright, again, we can use the same 3 questions. What's my variable? My variable should be x. What's being done to that x? In this case, it's being divided by 3. Alright, that symbol there means divide. Alright, so my variable is x. I'm dividing it by 3, so what's the opposite of divide by 3? Then I'm going to change the color so you can read a little better. So here's my problem. I'm going to multiply both sides by 3. If I'm dividing x by 3, then I'm multiplying both sides by 3. It's always the opposite. These will cancel out because 3 divided by 3 is 1, and 1 times x is x. And 5 times 3 is 15. So there's my answer. Now I could check it, and we're going to say 15 goes in for x. So 3 goes into 15 5 times, and that's my answer. Alright, what if we had something like this? There's 2 ways we could write it. We could write it like you see there, or we could write the x, the top number with the x, and put the 3 on the bottom. Either one is correct to set it up. It can be done just a little bit differently. Now, on the top one, I like using it, and I'm going to show it to you, and then I'll do the bottom one that I just erased so you can see how the difference is. Alright, so we have a fraction, and it's being multiplied to x. So again, you could ask yourself, what's the variable? X. What's being done to x? It's being multiplied by 2/3. Now, because it's being multiplied by 2/3, it's a fraction, we can do something called the reciprocal here. This is a kind of a special thing. So whenever you see a fraction, see this fraction here, and it's being multiplied to a variable, they're side by side, you can do the reciprocal of that fraction. So I'm going to rewrite this so you can see the steps perfectly. Alright, so it's 3/3 x equals 4. Now I'm going to do the reciprocal, which means I'm going to flip it. I don't like that 3/2 on this side. I'm going to erase it and redo it. But it's 3/2. Alright? Now, I can multiply straight across. And when I do, I get 3 times 2 is 6. 2 times 3 is 6. See how that works? Now this one, it's a whole number times a fraction. I'm going to pretend there's a 1 underneath it, and then they're both fractions and multiply across. So that becomes 12/2, because 4 times 3 is 12. 1 times 2 is 2. Now 6 divided by 6 is 1x, and 2 goes into 12 6 times, and there's my answer. And that's how you do this. Now, there is another way, and I'm going to show you real quick. This is the same example. Alright, we had 2/3 x equals, I can't write tonight, I don't know why. I'll try this again. Alright, so it's 2/3 x equals 4. That's a horrible, ugly, that's an ugly looking 4. 4. Alright, so here's another way. Remember how I told you could put this x here with the 2 here, so you can make it look like 2x. 2x over 3 equals 4. Alright, let's do the same thing. What's my variable? Well, my variable's x. It's being multiplied by 2, and it's being divided by 3. If you notice this 3 here, it's dividing into both of these guys here. So we have to get rid of the 3 first. So in this case, we're going to get rid of the 3. So anytime you see a 3 in a fraction that's got a bunch of stuff on top, you get rid of it first. So I'm going to multiply 3 to the top of both of these guys. What's 3 divided by 3? Well, these two will cancel each other out. It means it's 1. And 1 times 2x makes 2x. And 4 times 3 is 12. Now you can see that it's very similar to what we've been doing. What's my variable? X. What's happening to x? Being multiplied by 2. What do I do to both sides? I divide by 2. So x equals 6. Alright? That's how you can do that one. What would you do if you saw this? Well, remember, the x really has an imaginary 1 in front of it. So it's really negative 1x. So then you ask yourself, what's your variable? It's x. What's being done? It's being multiplied by negative 1. So you divide both sides by negative 1. So then your x equals, and 2 divided by negative 1 is a negative 2. Okay, in algebra we always have some kind of special case. So this right here is a special case, and I want you to watch this. And I think we'll do the special case in the next video to shorten this up a little bit.